Okay, welcome back. I had a question asked about when to do each of the following: product rule, quotient rule, chain rule. I think what happened here was some of the questions I had you try it a couple of different ways. The idea was you were trying to figure out what you liked best and whether there were questions where specifically a quotient rule worked better for you than the chain rule product rule combination. So the first thing I'd say is, oh rats, I didn't mean to do that. So I'd liken it to a question like this. Okay, so when we first learn about just doing some straightforward math with numbers, we always sort of start with bedmas. And of course, if I'm looking at this, bedmas tells me to work on the inside of my brackets first if there's something I can do there. And so if I follow that through, 5 plus 3 is 8, root 16 is 4. The second step of bedmas tells me to deal with my exponents. So 8 squared is 64, 4 cubed is 64, and 64 divided by 64 is 1. 64 divided by 64 is 1. So my answer is 2. Later on, about probably in grade 9, I guess, we learned some other things. One of which is that a binomial, we don't usually use just straight numbers at that point, but we learned that something like x plus 3 quantity squared expands to x plus 3 times x plus 3, and we end up with x squared plus, multiply the two terms and double it, 6x plus 9 if we expand that. So there's no reason why this wouldn't do the exact same thing when we think about the fact that x is just a number. It's a number that I don't happen to know the value of right now, but it could have been 5, it could have been any other number as well. So 5 plus 3 squared could be rewritten as 5 squared plus, multiply the 2 is 15 and double it, because you're going to get a 5 times 3 and another 5 times 3. And then final term squared is 3 squared. Extending this out, 25 plus 30 plus 9 times 2. My denominator, we also learned in, I guess, grade 9 that the square root is the same as exponent 1/2. So rewriting it this way is fine. Multiply my exponents to simplify here, 3 halves. Again, added these up, and then at this point, add these up, I get 64. I need a little bit more work, I guess, down here. Sorry, I need to click on that, and my pen's not allowing me to do that. There we go. So 64 times 2, I can rewrite the term 64 as 4 cubed. I can rewrite 16 from the denominator as 4 squared. So now I have 4 squared to the exponent, 3 halves in the bottom, and multiply those exponents is 4 cubed, and now again I have 4 cubed divided by 4 cubed. Clearly that is 1 as well, and the value 2. If I look for other options, sort of same first step here, add these values, take the square root here, so I have 8 squared times 2. We also know that what the exponents mean is 8 squared is the same as 8 times 8 times, 8 times 8 times the 2 that's already there. 4 cubed is 4 times 4 times 4. And then I have the option to divide 8 by 4. 8 by 4. Remember, multiplication and division back to bedmas. I can do them in any order, so I can do this or cancel them. You can think of it as canceling through a fraction. And then 2 times 2 is the same as the 4. And once again, an answer of 2. If I really wanted to, around this point right here, I could use the same rule that I used over here, and I could expand this to 50 plus 60 plus 18 in the numerator, which would be 110, 128. And then I could have maybe all the way back right here, sorry. If I had worked this out or worked one of these out, I remember my denominator would be 64. And so simplify this somehow to 64, either as we had done here or sort of expand it once we get to here, punch it into a calculator. 128 divided by 64 is also the value 2. Okay, so the point here is to recognize that all the rules I know are possible if we're in a situation where they exist. So the same is true with these questions. In some of the tougher questions we did once we saw the quotient rule, once we saw the chain rule, there were multiple options. If there's a quotient there, if there's a division there, you can use the quotient rule at that point. If you run into a division further along in your question because you started with a chain, you can use the quotient at that point. Okay, so if we just look at sort of the basics, product rule can be done anytime we have a multiplication. Two sets of expressions, or sorry, two expressions multiplied out. Whatever those happen to be, I can use the product rule. The quotient rule, same basic argument. Quotient means division. And so if I see something that looks like this, I can use the quotient rule. Now the chain rule is not a rule at the same level as these. The chain rule comes up anytime we have sort of this kind of a patterning, where there's brackets inside of brackets or an expression inside of a bigger expression, probably with exponents or something on them. So a question like f at x is, let's go x plus something like this is a classic chain rule. I have a bracketed expression with an exponent. And so I have an unknown term to the exponent 7, unknown terms to the exponent 7 when we take the derivative of them. Come out to 7, the unknown term, to the exponent 6. And then basically the chain rule says if we have an unknown term here other than just a term in x, then we have to do something with it as well. If this were just x to the 7th, we would be done because the term x, we know the derivative of x is just 1. If the derivative of the term in the brackets is not just 1, then there's more work to do. And so because it's x plus root 2x minus 7, we then extend the question to deal with this part. So we take the derivative of this next. Well, the derivative of this is derivative of x1, derivative of this, so 2x minus 7 to the 1/2 is 1/2 times the 2x minus 7 to the negative 1/2. Okay, so essentially what I've done here is looked at the term right there as if it were some unknown value to the 1/2. Anything in this form, 1/2 is multiplied out front, subtract 1 up here, we get a negative 1/2. And then again, if what's in here is not just x, then we have to work with it as well. And so then we would take the one extra step of, oh yeah, there's something more in here. It's not just an x, so I have to continue the question. The derivative of this piece inside is the number 2. Okay, so the template for you is if you are multiplying two expressions, it's a product. So we use the product rule. If you are dividing two expressions, it's a quotient. By definition, that's what quotient means. And so we can use the quotient rule. A chain rule is simply going to help us get into a question if we have sort of layers upon layers. Deal with the outside first, and then this is kind of your, the link of your chain in here. And it's sort of that part of the chain has to link up in the next step. So sort of you pull it out to the side, and so we have the first link, a second link, and oh wow, now I have a third link, because one of the brackets that I was dealing with did not have just the value x inside of it. So I'm going to make up a big one here. Actually, I'm going to pause the video and come back. Okay, so I took a moment to draw this up on paper. It was a little easier than writing it on the tablet. I'll send you a copy of the PDF of this. So I've done question 4H here on page 158. I had a question about it last night as well, so probably the old two birds with one stone was the best way to go here. So when I look at this question, I see a couple of options right off the bat. I see, first of all, a division in the question. There is the x squared minus 3 and on top, x squared plus 3 on the bottom. So I do have the possibility of doing a quotient rule. I also see something of the form a bracketed expression to an exponent with some non-x only stuff in the middle. And so I do have the chain rule as well. I chose to do chain rule here first. I did do the other one, and you'll see it in a second. So if I look at this, again, there's something here with an exponent 4, which is a chain rule just by definition. Anything to an exponent that is not, that is a non-x term on the inside is a chain rule. I suppose even if I wanted to be more honest about it, even if I had something like g at x is x to the 10th, technically that is a chain rule as well. I do 10 x to the 9, and then the derivative of this, which is just the number 1. Okay, so even the power rule in its basest form is a chain rule. It's just a chain rule where the exponent, or sorry, the derivative of the base is the number 1, and so we don't really need to take it that extra step. Oops, missed. Okay, never mind. That doesn't seem to be working. So all this said, basically I'm going to treat this like a chain rule to start. So my exponent was 4 on the outside. 4 comes down, multiplies by, if there is something here, it multiplies by it, there isn't. The base is unchanged, the exponent 3, and now I take the derivative of the base. The base itself is a quotient rule. And so, as I continue on, this part of the expression up here isn't going to change until I get to sort of the end of my simplification. The derivative of this part, so if I was thinking of it, if I was doing this on paper, I could basically ignore this for the next couple of lines. I'm just going to repeat it over and over, and I'm going to concentrate on as if this were my entire question. Okay, so I can pretend that my whole question is this section here, and that's all I'm working on now. So I have a quotient rule over here, and oh yeah, by the way, there's something in this box that I have to worry about as well. So the derivative here is take the derivative of the numerator, which is just 2x, leave the denominator alone, subtract, numerator is left alone, derivative of the denominator, denominator squared. Okay, so just this section here becomes this section here. And that was pretty messy, so I'm going to just erase those. But that's basically what we're doing at this point. And again, I would liken it to just the types of questions that you've done going from grade 8 through grade 9 to grade 10 to grade 11. A lot of the material is similar, especially the algebra. The questions are just bigger. So once you've done one part of it, you kind of leave it alone. You factor out this section and it just remains in the front of the question until we get to a point where we're ready to simplify or declare our final answer. And so I'm going to multiply this through 2x cubed plus 6x. This is minus x squared times 2x, which is minus 2x cubed, and then minus negative 3, which is positive 3. Positive 3 times 2x is plus 6x. And now it's just sort of finishing up. Again, out front, I haven't touched this. This simplifies to the 2x cubed subtract 12x over that. And now 4 times 12 is 48x. This term on top, this term on the bottom. Sorry, expression. I often use the word term, but it's not a mathematical term. Second option is I look at the exact same question and think of it as a quotient rule, in which case, instead of having the one bracket with a 4 on the outside, I recognize the exponent is on both the top and the bottom. And so I'm going to treat it as a quotient rule, which means taking the derivative of the numerator first, multiplying by the denominator unchanged, minus numerator unchanged times the derivative of the denominator over the denominator squared. So the denominator is a fourth power already. It's going to have a square on it. The derivative of this section, again, ignoring all the rest of the question, the derivative of this section is 4 times this bracket cubed, so 4 times that bracket cubed, then take the derivative of what's inside the brackets, which is just a 2x. And I just kind of declared that off to the side in case somebody wasn't sure. This is just, if that were the entire question, take the derivative of that as a chain rule. 4 is multiplied out front. We end up with an exponent of 3 times the 2x. Did basically the same thing with this right here. That's just, if I was to do just the derivative of that part, that's what I get. And so this is right in here, 4 times the brackets cubed times, again, the 2x. Okay, so that was that part, that was that part, and everything else is unchanged. Other than, I guess I simplified the bottom here, 4 to the exponent 2, which is just the 8. We multiply the exponents when it's an exponent to another exponent. And again, at this point now we're doing algebra. This is not really the calculus, but we do need to be able to do it to simplify our question. And so 4 times 2x is 8x out front. I have this term cubed, this term to the 4th power. Same thing here, there's a 4 and a 2x, so 8x out front. That term to the 4th power, that term cubed, all over the denominator. And now I have common factors of 8x and 8x, x squared minus 3's, and x squared minus 3. I have 3 of them here and only 4 of them here. And I have x squared plus 3's, 4 of them over here, x squared plus 3, 3 of them over here. And so there's common factors throughout. The common factors, the 8x, I have x squared minus 3 cubed in both sections, and x squared plus 3 cubed in both sections. What I'm left with is 1x squared plus 3 in the front part, minus 1x squared minus 3 in the second part. And then it's not super clear here, but what I've done is divided the x squared plus 3 cubed by some of the ones in the bottom and ended up with 5 of them remaining, so x squared plus 3 to the 5th in the denominator. I was squeezing this in at the bottom of the page, so it's a little bit messy. This whole bracketed expression, the square brackets on the end, I have x squared minus x squared and 3 minus negative 3, so that whole thing simplifies to 6. And then I have 6 times 8x, 48x out front. Again, my numerator has this term cubed, this expression cubed, and down here I have this one to the 5th power. So just trying to make the point, both questions or both methods were a little messy. In this case, I think the chain rule was the nicer way to go. I don't think I knew that going into the question. I would have done the chain rule, but that's more out of force of habit probably than anything else. I certainly can do the quotient rule, and then we end up with sort of mini chain rules inside. What you see is we did a chain rule first in the one case and ended up still ending up with a quotient rule. In the second case, we did the quotient rule first, but then we ended up with smaller chain rules inside. So both were necessary, and again, both dealt with different parts of the question, just sort of when that specific type of expression showed up. So I'm going to stop there. I'll post the PDF of those two solutions, and hopefully maybe that helped clarify a little bit. The video probably ran fairly long, 20 minutes, yikers. Okay.